So the first thing I'm going to do is identify, let me try this color maybe, identify my starting point. So what's my starting point for this very first equation? It is -1, -2. Good. There's my starting point. I'm going to mark that on my graph. -1, -2. I am doing some dilations here. What kind of dilations am I doing? I'm doing vertical stretching. All right, so I'm going to put my parent function table. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Maybe I need the square root of 16 is 4. I'm not sure. And because I'm doing a vertical stretch, what happens to the table? It's multiplied by 3, right? So this is multiplied by 3. So 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. All right, so I'm ready now to use my counting scheme to plot a few more points on my graph. So I go to my starting point, and I'm going to go to the right 1 and up 3. To the right 1 and up 1, 2, 3. From my starting point, I'm going to go to the right 4 and up 6. So here's my starting point, 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. From my starting point, I'm going to go right 9 and up 9. Right 9, up 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. 6, 7, 8. So here is my first graph. Pretty straightforward. Could you guys do that on your own without any help? Okay. Second one. Second one here. Before I can identify my starting point, what do I have to do? Factor out the b value. So if I pull out a -1, I'm left with x minus 8 plus 7. So now I can identify that starting point at +8, +7. All right. So +8, +7, 1, 2, 3, 4, 5, 6, 7. Oh, hey, all right, I have one of my solutions already. All right, I have one solution. Let me just make a note down here, because that's one of my points of intersection. I have one solution at 8, 7. I might have more than one. We'll see. All right, now I'm going to go to my table of my parent function. So I have my 1, 1, 4, 2, 9, 3, 16, 4. All right, so what am I doing to the x's? I'm dividing them by -1. Now, multiplying by a -1 is the same thing, but I just wanted to practice so you remember. So this is dividing by -1. So this just changes all those signs. What am I doing to the y's? Multiplying by -3. So 1 times -3 is -3. 2 times -3 is -6. 3 times -3 is -9. 4 times -3 is -12. All right, so I've got my starting point at 8, 7. This tells me to go to the left one. The -1 tells me go to the left one and down 3. To the left one, down 1, 2, 3. So here's this coordinate. From my starting point, I'm going to go to the left 4 and down 6. 1, 2, 3, 4, and down 1, 2, 3, 4, 5, 6. From my starting point, I'm going to go to the left 9 and down 9. This is 9 and this, oh, here we go. There's my next one. So here is this second square root graph. And I have found my second solution right there at -1, -2. So there are my two solutions. These graphs intersected twice. All right, so here I'm looking at a square root function and a quadrat. Oh, we have to remember how to graph quadratics. That's okay, because I still know the counting scheme is just the opposite of square root. So I'll be okay. All right, so let's start with that square root first. I start with the square root first. If you want, you could rewrite this as pulling out that b value. It's not really necessary because there's only one term under, the radical, but if that's easier for you to see, you could write it in transformation form. So what's my starting point here? 0, -4. Before we go any further, can you tell me what the transformations on the parent function are for this equation? Jonah, tell me what the transformations on the parent function are in order. Yes, horizontal compression.
Vertical compression.
Nope. No, what does this do? It's a vertical reflection, and then the -4 is down 4. Okay. You guys good with that? We have to be able to do that come Tuesday. All right, so I'm going to mark my starting point 0, -4, 1, 2, 3, 4. I'm going to go ahead and make my table of the parent function. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. What am I doing to the x's? Divide by 2, right? Dividing by 2. So 1 divided by 2 is 1/2. 4 divided by 2 is 2. 9 divided by 2 is 4.5. 16 divided by 2 is 8. What, if anything, am I doing to the y's? Times -1. Times -1. That's what this negative out here is doing. So this will be -1. This will be -2, -3, -4. All right. So I start at my starting point. I'm going to go to the right 1/2 and up 1. Right about there. From my starting point to the down 1. Hello. Missed that. To the right 1/2 down 1. To the right 2 down 2. I'm going to skip the 4.5. I'm going to go to the right 8 and down 4. 1, 2, 3, 4. Puts me here. All right. So here is my square root function. Now, what kind of form is that quadratic equation in? It's in standard form, but I could very easily manipulate it to vertex form just by putting parentheses around the x. And I'm just going to go ahead and put the 0 in there to just make it plainly obvious that my HK is 0, -4. Oh, hey, look what we've done. We found one of our solutions. So one of our solutions is at 0, -4. All right, so with quadratics, these are an inverse of a square root, so I can just flip the x and y's for the parent function. 1, 4, 9, 16. Or I could plug it in. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. What am I going to do to the x values? I'm going to do nothing to the x values. Do you see a b value? No. I have an a value, though. My a value is -1/2. I'm going to multiply all this by -1/2. So this will be -1/2. 4 times -1/2 is -2. -9/2, and this is -8. All right, so here are my directions from my table. At the starting point, I'm going to go to the right 1 and down 1/2. And remember, there's a mirror image on the other side. I'm going to go to the right 2 and down 2. And there's a mirror image on the other side of the axis of symmetry. And that's about all that I'm going to get in here. But it was enough to help me find my second solution. My second solution is at 2, -6. Okay, so I had one solution here and one solution at 2, -6. Do you think I'm always going to have 2 solutions? Nah. What if that parabola was had the same HK but was flipped up? then it would have only had one solution. If that parabola was concave up and moved up a few units, then I would have no solutions. Okay, so don't always expect to get two solutions. You might have one solution, you might have no solutions. So let's say, for instance, I took this first equation and I changed the equal sign to a less than or equal to. So I already have the graph on my paper. Less than, does that usually mean above the line or below the line? It means below the line. So I'm going to shade this green below the line. Now here's the key with square roots. But where the vertex is, where that starting point is, I'm going to drop the line down vertically, and I'm not going to cross it. All right, that's it. That's all there is to that. So let me take the other one, and how about if I shade this one greater than or equal to? We're going to be above the line. So same idea. Wherever your starting point is, you're going to kind of extend it, and then you're going to stay to the side of it, if you would. So my solution in this case is going to be this little area in here. If I had flipped-flopped my greater than and less than signs on both of them, I don't think I'd have any intersecting shading. I wouldn't have had any solutions. So you'll have a few of these where you have to do a little bit of shading. You have to do a little bit of shading. Let's answer this question here. We're asked if these two graphs are inverses of each other. Well, how would I be able to prove that? I could do so algebraically, I could do f of g of x. Does that equal x? Does g of f of x equal x? Algebraically. If I had a piece of patty paper, I could put it down and reflect the graph over the y equals x axis. What about, now these are not the tables of those equations. This is a counting scheme. But what if I had the tables? What would I be looking for? If the x's and y's were switched. Okay. Let's take a look at your homework for a minute. And I want to look specifically at number 1. Let's look at number 1 for just a second. I want to look at this equation, y equals x squared minus 2x minus 5. That is not factorable. There are no factors of -5 that add to -2. So factoring isn't an option. I want to remind you that I can change this equation into vertex form. I could complete the square, if you remember that, or I can find the vertex. So the formula for the vertex is -b over 2a. And so in this equation, my b value is -2. So negative times -2 over 2 times 1, right? Because my a value is 1, my b value is -2, my c value is -5. So I end up with 2 over 2, which equals 1. So my vertex, my HK, is 1 comma something. Do you remember how I find the k value? I can plug the 1 up into the equation, right? So my k value is found by replacing the x with the h value we just found. So 1 minus 2 minus 5 is -6. So now I can rewrite this equation here as y equals, the a value is 1, so it still has an a value of 1, x minus 1 squared minus 6. Are you guys more confident graphing that equation? Yeah, because you're going to start with the vertex and then just do the counting scheme. Over 1 up 1, over 2 up 4, over 3 up 9, over 4 up 16. All right,